Inverse variation. So when one variable is in inverse variation or inverse proportion with another variable, one is the constant multiple of the reciprocal of the other. Okay, what this means is that as one variable increases, the other decreases. And one decreases, the other increases. So some examples of this in real life for inverse variation and proportion is that the more slices of pizza, the more slices you cut a pizza into, the smaller the size of each slice. Okay, so the more slices, the smaller the size. The more workers there are in the project, okay, the less time it takes to complete. The fewer people sharing a house, the higher the rent each person pays. Okay, they're just some real life examples of inverse variation. So if y is in inverse variation to x, then we are using y equals k on x as our function. This is where k is a constant called our constant of variation, or it is constant of proportionality. So if x decreases, that means we're going to, if x increases, y decreases. If x decreases, y increases. If x is doubled, we have y is halved. If x is halved, y is doubled. We have another way of describing this relationship is if y is inversely proportional to x, or y varies inversely with x. So our graph of inverse variation is our graph of y equals k on x, which is what we looked at in the very first lesson of this new topic, which is our hyperbola. All right, and it's just our hyperbola in the first quadrant only, so we only have our positive values of x. We're just going to look at our examples. So our examples are on our next page. All right, our first example is that we are building a shed. When we build a shed in 12 hours, it requires 3 builders. If the number of builders n is in inverse variation to the amount of time, t hours, then we want to find the equation for n in terms of t. So it's going to be n equals k over t, because we are using y equals k on x. When we have inverse variation, that is the formula we want to look at. All right, what we're going to do is we need to sub in n equals the number of builders, which is 3, and t equals our hours, which is 12. So we will have 3 equals k over 12. We are then going to multiply both sides by 12 to get k equals 36. And therefore our equation for n in terms of t is n equals 36 on t. That is our equation for building a shed when in 12 hours it requires 3 builders. We can now use this equation for our inverse variation to find and answer these next few questions. So part B, we have the number of builders it would take to build a shed in 9 hours. So we're going to start off with our n equals 36 on t. Now we're trying to find n, the number of builders. So we have our shed in 9 hours. So we're going to sub in t equals 9. That means we will have n equals 36 on 9. So n equals 4. So therefore it takes, stay still, it takes 4 builders to build the shed in 9 hours. Now, if Maya was here, I'd be asking her, it's a worded question, we've got to write it in words. Hopefully she hears that when she listens to this video. Okay, so that's one style of questions we can get. So we get our denominator and we can substitute it in. The next one is to find out how long it would take 2 builders to build the shed. So what we want to do is we start off with that equation, our n equals 36 on t, and we are going to sub in n equals 2. So we will have 2 equals 36 on t. Now what we're going to do is we want t to be the subject. So our t and our 2 are going to swap spots. So we'll have t equals 36 on 2, which t equals 18. So therefore it takes 2 builders (18 hours) to build the shed. All right, flip the page when you are ready for me. So pretty much with these style of questions, you need to be looking out for the word varies inversely or inverse variation, and that tells you that you should be using y equals k on s, or k on x, sorry, because in previous lessons, what we have done is we did direct variation, and direct variation is just y equals kx. So we have to make sure that we know the difference between the two. Okay, our next example is the faster a car travels, the less time it takes to travel a certain distance. It takes the car 2 hours to travel to Nelson Bay at a speed of 80 kilometers per hour. If the time taken t hours varies inversely, there's our keyword, with the speed, s kilometers per hour, then we want to find the equation for t. So we have seen varies inversely, so that means we want to use y equals k on x. So we are trying to find if the time taken t hours varies inversely with speed. So we're going to have t equals k on s. Okay, time is written first in this question, so that's why it's the subject. And it also says find the equation for t. Okay, what we're going to do is we're going to sub in the information given to us. So we have been given the speed of 80 kilometers and we have been given 2 hours. So that means we're going to sub in t equals 2 and s equals 80. So we will have 2 equals k on 80. We can then just times both sides by 80 to get k equals 160. So therefore we get t equals 160 on s. And that is then our equation that we're going to use for the rest of our questions. Okay, part B, it says find the time it would take if travelling at 100 kilometres per hour. So we start off with that formula, t equals 160 on s. We are going to sub in s equals 100. what we get is T equals 160 on 100. T equals 1.6 hours. On our calculator, we can convert to minutes and hours. How we do this is we use our degrees, minutes, second button. Okay, on our calculator. So when we press 1.6 degrees, minute, second button, what we get is T equals 1 hour and 36 minutes. Okay, so therefore, car takes 1 hour and 36 minutes to travel at 100 kilometres per hour to get to your destination, to get to Nelson Bay or wherever it's going. Okay, part C. We want to find the speed at which the trip would take 2.5 hours. So we start off with that equation. So we'll have T equals 160 on S. We have time, so T equals 2.5 hours. Let's not muck around with mixed numerals. Let's change it to a decimal straight away. So we'll have 2.5 equals 160 on S. We are going to make our 2.5 and our S swap spots. Because we times up our S, we divide both sides by 2.5. So we get S equals 160 over 2.5. And S equals 64 kilometres per hour when we put that into a calculator. So therefore, the car travels at 64 kilometres per hour if the trip takes 2.5 hours. Okay, now we have the great pleasure of graphing this equation. All right, so we have our equation T equals 160 on S. We can use a table of values, so I've provided one here for you, but we also can just do it in our head, our table of values, to plot our points. So when we substitute in S equals 20, we get T equals 8, S equals 40, T equals 4, S equals 60, T equals 8 on 3. Okay, 8 on 3 as a decimal is 2.6 repeater. If we need it just to help us out with our axis. When we substitute in 80 for S, we get T equals 2. 100 for S, we get T equals 1.6. And when we substitute in 120, we get 4 on 3, which is 1.3 repeater. Okay, on our axes, we are going to go up by 20. Now, we don't quite have enough to get to 120, but that's okay. We get the general gist of the equation going on. And then we're going to go up by 1s each box. Or if you want to be a bit lazy, you can go up by 2s. Oh my gosh, I did it again. Every second box. Now, one thing we must do is label our axes. So our S-axis is our X-axis, and where our Y-axis normally is our T. All right, and then we can just plot our points. So at S equals 20, T equaled 8, 40 was 4, 60 was 2.6, 80 was 2, 100 was 1.6. Okay, this is a nice smooth curve going through our points as if it's a hyperbola in our first axis. All right, we probably should label a key point. So I'm just going to pick the point 40 and 4 and then write our equation t equals 160 on S on our graph.